Imagine for a second that we discovered a material that was literally perfect. It's as strong as the toughest steel, but it's so light it feels like it shouldn't be real. It's a metal that doesn't rust, doesn't corrode, and can survive in the crushing depths of the ocean or the freezing vacuum of space. And here's the craziest part. Your body doesn't even realize it's there. You could have a piece of it replacing your hip or your jaw, and your immune system would just accept it. It sounds like a miracle material from a Marvel movie, right? But this metal is real. It's called titanium. And it's not rare. It's everywhere. It's in the dirt in your backyard, in the sand at the beach, and in the rocks of the Earth's crust. In fact, it's the ninth most abundant element on the planet. So if it's so perfect and so common, why isn't everything made of it? Why are our cars still made of heavy steel and our soda cans made of flimsy aluminum? The answer is one of the most frustrating and fascinating stories in the history of science. For 150 years after we discovered it, titanium was essentially a forbidden metal. We knew it was there, we knew it was amazing, but we couldn't use it. It was like having a locked treasure chest with no key. Today, we're going to find out how we finally broke that lock and the insane high-stakes process we use to make it today. Our story starts back in 1791 with an English clergyman named William Gregor. He was an amateur scientist who loved poking around in the black sands of Cornwall. He found a mysterious metallic ash that he couldn't identify. A few years later, a German chemist named Martin Klaproth found the same thing and named it titanium, after the Titans of Greek mythology. He chose that name because the bond this metal formed with other elements was so incredibly strong, it seemed like only a god could break it. And that was the problem. You see, titanium is the ultimate stage 5 clinger of the chemistry world. It absolutely loves oxygen. In nature, you will never find a piece of pure titanium just lying around. It is always, 100% of the time, bonded to oxygen or other elements in a rocky ore. This bond is so powerful that for a century, every time scientists tried to separate them, they failed. If they heated it up, the titanium would just suck in more oxygen from the air and turn into a useless, brittle mess. It was a metallurgist's nightmare. It wasn't until the 1930s that a scientist named William Kroll finally figured out a way to cheat chemistry and set the metal free. To understand how we make titanium today, you have to stop thinking about traditional blacksmithing and start thinking about a high-tech heist. We can't just melt the rocks, we have to trick the titanium into letting go of its oxygen. We do this through something called the Kroll process. It starts with a chemical transformation. We take the titanium ore and hit it with chlorine gas and carbon at blistering temperatures, about 1800 degrees Fahrenheit. This creates a liquid called titanium tetrachloride, or TiCl4 as the engineers call it. This liquid is nasty, volatile, and highly reactive, but it's the first step in getting the oxygen out of the way. But we're not done. Now we have to turn that liquid back into a solid metal. This is where things get really intense. Imagine a massive sealed stainless steel pot the size of a small room. Inside, we have to create a perfect safe zone. We pump out every single molecule of air, because if even a tiny bit of oxygen touches the hot titanium, the whole batch is ruined. We replace the air with argon, a lazy gas that doesn't react with anything. Then we fill the pot with molten magnesium. Remember those bright white sparks from high school chemistry? That's magnesium. It's even more desperate for chlorine than titanium is. When we drip the TiCl4 liquid into the pot, the magnesium literally rips the chlorine away from the titanium. What's left behind at the bottom of the pot is a strange gray porous mass that looks like a rock from the moon. We call it titanium sponge. It's pure, but it's not a shiny metal yet. To get the final product, we have to take that sponge, crush it up, and melt it in a giant electric furnace, again in a total vacuum, multiple times. By now, you're probably starting to see why your bike frame or your watch isn't usually made of titanium. The process is a nightmare. Think about it. You need massive amounts of electricity to run those furnaces. You need expensive magnesium to act as the bait. You need specialized airtight facilities that can handle vacuums and inert gases. And the whole thing is a batch process. You can't just run a conveyor belt of titanium like you can with steel. You have to make it one giant, expensive pot at a time. This is why titanium is often called the space-age metal. For a long time, only governments and the military could afford it. In fact, during the Cold War, the U.S. wanted to build the SR-71 Blackbird, the fastest plane ever made, out of titanium, so it wouldn't melt from the heat of the air friction. But they didn't have enough titanium. So they actually set up fake companies to buy the metal from their biggest enemy, the Soviet Union, just to build their spy planes. So, was all that effort worth it? Absolutely. Titanium changed everything. Because it's so light and strong, it allowed us to build jet engines that don't fall apart and spacecraft that can survive the trip to Mars. Because it doesn't rust in salt water, it's the only reason we can have deep-sea sensors and massive desalination plants. But the most human impact is in medicine. Before titanium, if you broke a bone or needed a joint replacement, your body would often fight against the metal implants. But titanium has this incredible property where it forms a thin, invisible layer of oxide instantly that the human body thinks is actually bone. It's called osseointegration. Your bone cells will actually grow onto and into the titanium, making it a permanent part of you. From a pile of black sand in England to the literal bones of our modern world, titanium is a story of persistence. It's a reminder that sometimes the most valuable things in the world aren't hidden in a secret cave. They're hiding in plain sight, just waiting for us to be smart enough to figure out how to use them. The next time you see the shimmering gray of a titanium watch or the wing of a jet plane, remember the forbidden metal. Remember the 150-year struggle, the Tickle 4 liquid, and the giant vacuum pots. We didn't just find titanium, we fought for it. And that's what makes it one of the most fascinating materials we've ever mastered. What other impossible materials do you think are still hidden in the dirt beneath our feet? Let us know in the comments, and don't forget to like and subscribe for more deep dives into the science that built our world.